All right, so we're going to continue our mini lecture series here on VCE Specialist Maths 3 and 4. We're going to look at the sine and the cosine rule. So these first few lectures need to be familiar with these ideas in order for the course to make any sense. So the sine rule is something that would have come up um, earlier on in your maths career, hopefully. So we're going to look at a demonstration of that. We're going to look at when to use it, and then we'll also look at the cosine rule as well and when to use it. So let's jump into it. Let's look at the sine rule. The sine rule basically says this. The ratio of A over sine A equals the ratio of B to sine B, which equals C to sine C. Okay, so that's our rule. It's not a proof, obviously, but the proof is actually pretty straightforward. What we would just need to recognize is that lowercase letters represent the side lengths. So these lowercase letters represent the side lengths. These capital letters represent the angle. Yeah, the relevant angles, and they're always opposite each other. So capital A is opposite this side length. So this angle, capital A, is opposite this side length, lowercase a. Similarly, capital C angle is opposite lowercase c side length. So when we're going to use it is we're going to use it to find unknown quantities when one side and two angles are given. So for example, you get given one side and you get given two angles, you can find the other information, or you get given two sides and a non-included angle. So for example, you get given this side and this side, you don't get given the included angle, you get given some other angle, such as this one over here. Okay, so that's basically what the sine rule says. And as you can see here, the ratio always stays the same. So as I said, a little demonstration, if we move things around, you can see that the ratio is maintained, right? No matter how I make my triangle, the ratio of this side length to this angle is the same as the ratio of this side length to that angle. Which is pretty interesting, I think. Um, yeah, so obviously an important rule that you need to be aware of because it has a whole bunch of applications in trigonometry. So cool. What we'll do now is talk about the cosine rule. The cosine rule is this. I like to think of it as Pythagoras on steroids a little bit. It says a squared equals b squared plus c squared minus 2bc cos a. So let's just make some sense of that. If this is the side length a, and this is the side length b, as we can see, and then this is the side length c, we can say that a squared, so this side length squared is equal to all this stuff. It's equal to b squared plus c squared minus two groups of b times c multiplied by cosine of this angle in here. Okay, so yeah, as you can see again, a squared in this case is 8.72 squared, which is 75.96, and it's also equal, so you can see that it's equal to all this stuff over here. So as we change them, we can see that the equality holds, right? So I think that's pretty interesting. And you're probably wondering when would we use that? Well, we would use that when we have two sides and an included angle are given. So for example, you're given this side and this side length, and you're given the included angle. You can use that to find other information by just doing some simple rearrangement of the formula. You can also use it to find angles when three sides are given. So if you get given all three side lengths, you can use it to find the angles inside the triangle. So pretty useful, I think. Good luck with everything you're doing. Hopefully that clarifies the cosine rule and the sine rule a little bit. Good luck.